Myself, Dr. Naresh Kumar, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. Today, I want to discuss the topic which is very important, that is differential equation. I have taken one lecture on this topic and I have given some basic information of the topic. So now I discuss further methods which are helpful to solve the differential equation of first order and first degree. So now the following methods are used to solve the ordinary differential equations of first order and first degree. Here we are mentioned several methods like as below. Method 1, variable separable. Method 2, change of variable. Method 3, homogeneous differential equations. And method 4, linear differential equation. Method 5, Bernoulli differential equation, or another name of this method is non-linear differential equation. And last name of this differential equation is reducible to linear differential equation. So now in first day we have first problem. I am solving some problems based on method 1. But we have discussed this method in last lecture. So now continue this method to solve the problem. Method 1 is variable separate. So here problem 1, I am taking this sec square x into tan y dx plus sec square y tan x dy equal to 0. So here we have taken here formula. We are taking here variables as a separate. Then we can integrate this question. This differential equation we can integrate. So here we see that sec square x. This is the function of x. And next tan y. This is the function of y. But there is multiplication of both function here into this. Into dx. Dx means integrating with respect to x. So here integrating with respect to x, then here is not any function of y. So this is wrong. Tan y is wrong here. Next plus in second term, sec square y. This is the function of y into tan x. And here dy. Dy means integration with respect to y of the given function of y. But here is function of x, tan x. Tan x is wrong here. So we remove from this side tan x equal to 0. So here variables are separate means here integrating with respect to y. So in this side only function of y. And in this side is function of only x. But all functions are in multiplication. So we can apply here cross multiplication. Now apply cross multiplication. Apply cross multiplication. This is the method multiplication. With the help of this method, we can separate the function. So first we write here, so sec square x into tan y dx. This equal to minus sec square y into tan x and dy. So now cross multiplying sec square x upon tan x and dx equal to sec square y upon tan y and dy. Integrating on both sides, let tan x equal to u and tan y equal to v. Differentiating with respect to x, then sec square x dx is equal to du and sec square y dy equal to dv. These values putting in above integral. Then we get here du upon u equal to minus dv upon v. So this implies that log u equal to minus log b plus log c. C an arbitrary constant. So here is log u plus log b equal to log c. This implies that log ub equal to log c. So log is cancelled, u into v equal to c. Putting the value of u, putting the value of u and v. Then we get here u is 10x and into 10y equal to c. This is the solution. This is the solution of problem 1. Now next problem. This problem again based on variable separable. So problem 1 is dy dx equal to e to the power x minus y plus x square into e to the power minus y. So here we are making variables separate. Then we integrate. If variables are separate, then function is integrable. So here first of all I am putting here in bracket and cross multiply. I am doing cross multiply here like this. So here is dy and this is equal to e to the power x into e to the power minus y plus x square into e to the power minus y and into dx. So now here e to the dy, this equal to e to the power minus y is common. E to the power minus y is common. So here is e to the power x plus x square and into dx. So here this function is not suitable here. So we are here taking like this, cross multiply this. So dy upon e to the power minus y equal to e to the power x plus x square into dx. Now we write this e to the power y. This function taking in numerator. So when we are writing in numerator, then this minus convert into plus. So e to the power y into dy and equal to e to the power x dx and plus x square dx. Integrating on both sides. So this function, every term, this term, every term is variable separate. So we can integrate this function. So now e to the power y, integration of e to the power y is e to the power y and equal to e to the power x integration of e to the power x plus x cube by 3 plus c. C is an arbitrary constant. So this is complete solution of 1. This is complete solution of problem 2. Problem 1. Now next, again this problem is 3. Some problem again, this problem based on again variable separable. So how we can solve this problem? So this is very easy problem and here this dx dy equal to 0. So here is dy equal to 0. So this term is wrong here. Only this result is there. E to the power y, this term is wrong. So I am cancel this term. Only this term is correct. So e to the power y and plus 2 here into sin x and dx equal to this term I am taking to this side. So this result is e to the power y and into cos x into dy. So now I am taking variable separate. Here is dy. So all function y taking right hand side. Here is dx. So all function taking to left side of x. So here is sin x upon cos x and dx. This integrable function and equal to e to the power y upon e to the power y plus 2 and into dy. Integrating this. So now solving this. This is the 10x. This is 10x. 10x and dx. So integration of 10x is log sec x and equal to this integration here e to the power y adding 2 and subtracting 2. So here e to the power y plus 2 this. So this result and dy. This result writing 1 minus 2 and 1 upon e to the power y plus 2. e to the power y plus 2 and dy. So now integrating this is log sec x. So here multiplying by e to the power minus y. So log sec x equal to this x and minus 2. Now multiply by e to the power minus y and upon here 1 plus 2 e to the power y. 2 e to the power minus y and dy. So integrating of this is the differential of this. So here is x and here log of plus minus 2 into 1 upon 2 log of 1 plus 2 e to the power minus y and plus c. This is log sec x. So this is the complete solution of this differential equation. Next one is this. Now we discuss here another method number 2, that is change of variable. How we can change the variable in our differential equation, and after changing the variable, then this differential equation convert in variable separable. This method 2 convert in method 1 if we change the variable. So here in this method, the type of the question is as follows: dy dx plus equal to fx plus y, or dy dx equal to fx plus y plus 3, means in any bracket there is some algebraic function. In any bracket there is some algebraic function this type. Nothing is there, only this type of function. Suppose function in place of x is x plus y plus 2, x plus y minus 2, x minus y plus 2, x plus y plus 3, 2x plus 3 plus 3y plus 4. So here I am giving 3 examples. Example number 1 is this, example number 2 is this, and example 3 is this. These are questions basically in method 2, change of variable. Here f is a function, maybe trigonometric function, algebraic function, logarithmic function, inverse trigonometric function, any type of function. But in place of x is simultaneous, both variable occurs, x plus y plus 3 and 2x plus y. So now in this function we are considering for change of variable, means here in first question dy dx, this is equal to function x plus y. Suppose this question we are solving, then here let x plus y is equal to u. This x plus y in place of x, in place of one variable. So x plus y is a variable. This function depend on x plus y. So x plus y we convert in any one variable. So I am considering x plus y equal to u. So differentiating with respect to x on both sides. So here is 1 plus here dy dx, here is equal to du over dx. This equation 2, this 2 equation putting in 1, from 2 putting in 1. So here is dy, putting dy dx. So dy dx means du over dx minus 1 equal to fu. So now du over dx equal to fu plus 1. Now, so this function here variable now apply variables are separable. This method is apply variable separable. Then this result is du upon fu plus 1 equal to dx, integrating on both sides. So this integration fu, so this equal to x plus c. So this is answer, du upon fu plus 1. So this is answer of this differential equation. Okay. Now here, procedure to solve the differential equation, which is I am completing. So I am explain again here. So procedure to solve the differential equation, dy dx equal to fx plus y, this is equation 1. Let us consider x plus y equal to t, this is the equation 2. And differentiating with respect to x on both sides 2, then we get here x ka differential of x with respect to x is 1, differential of y with respect to x is dy dx, differential of x with respect to x is 1, differential of t with respect to x dt over dx. So now we find out the value of dy dx. So dy dx equal to dt over dx minus 1. Now this 4 equation from equation 2 and equation 4 putting in equation 1. So equation 1 is dt upon dx minus 1 is equal to ft. This equation number 5. Now again this 1 plus dt over dx, this is equal to ft plus 1. This equation 6. Now this t function, this is the function of t. So I am writing this type dt upon ft plus 1 and equal to dx, integrating on both sides. So this side is x plus c. But here ft is unknown function. Here ft is unknown function. Unknown function. So ft integration is not possible. Integration is not possible. Okay. If ft is known, then we can integrate this function. Okay. So now next question here, dt upon dx minus 1 equal to ft, dt over dx equal to ft plus 1, this equation 5. In equation 5 we apply method 1, variables are separable, and now apply cross multiplication in equation 5. Here I am writing 1 and here cross multiply. So I am taking here dt equal to ft plus 1 dx. But here variables are not separate. Here is function of t. Here is dx. So taking variables separate. Here taking variables separate here. Then we get here dt upon ft plus 1 dx. This equation 6. Integrating both sides to 6, we get this one. So now integrating here dt upon ft and plus 1 equal to integration 1 is x and plus c. So here ft is unknown. ft is unknown. So answer is this. If ft known, then we can integrate. So this is complete answer. Dt upon ft plus 1 x plus c. In this integral, if function is known in LHS, then we find complete solution. Now problem based on method 2, change of variable. This is the problem. How we can solve this problem? So now I am solving this problem completely. Here d by dx is equal to x plus y the whole square. This is equation 1. Now let us consider here is in place of x square. So here it should be x square, but not x square. In place of x is x plus y. X plus y here. So in place of x plus y, here is two variable, x and y variable. But now we change in single variable. X plus y change in single variable. So I am writing here x plus y equal to u. This equation 2. Differentiating with respect to x. On both sides. So here differential of x is 1 plus differential of y is d by dx equal to differential of u is du over dx. So now d by dx, this is equal to du over dx minus 1. This equation 3. Now this value and this from 2 and 3 putting in 1. From 2 and 3 putting in 1. Then this result is du over dx minus 1 equal to, this is u square. So now du over dx equal to u square plus 1. So now du equal to u square plus 1 and dx. Here apply variable separate here. So dx du upon u square plus 1 and equal to dx. Now integrating on both sides, plus c constant. So u square plus 1 tan inverse u. Tan inverse u equal to x plus c. Putting value of u. tan inverse u means x plus y equal to x plus c. This tan inverse taking x plus y equal to tan x plus c. Y is equal to tan x plus c minus x. This is solution, complete solution this. So this is the complete solution with the help of change of variable, and we can find now when we start change of variable. Here is two variable in place of x, then we convert x and y in one variable, then this result convert into variable separate. Next problem. Problem based on method 2. Change of variable. Again solving this problem. This problem also very easy. So now here dy dx is equal to 1 plus 10 y minus x. This is equation 1. Apply change of variable. Apply method change of variable. Change of variable here. So here y minus x is in place of x. So y minus x convert in single variable t. Let. Now differentiating with respect to x on both sides. So here dy dx minus x ka 1 equal to dt over dx. This equation 1, this 2, and this is 3. This equation 3. Now taking value of dy over dx equal to dt over dx and plus 1. This equation 4. From 2 and 4. From 2 and 4 putting in 1. Putting in 1. So dy dx means dt over dx plus 1 equal to 1 plus 10 t. 1 is cancel here. So dt over dx equal to 10t. Now cross multiplying. So here dt is equal to 10t into dx. This equation number 5. Now variable separate. Apply variable separate. Vs variable separate. So here dt upon 10t equal to dx. Now this is cot t dt equal to dx. Integrating on both sides cot t. Integrating on both sides. So cot t. Integration cot t का मतलब sin cos upon sin. Sin का cos. तो log sin t. Log sin t equal to x plus c. So this is answer. This is complete solution of this equation. This is the problem solved with the help of change of variable. Change of variable means in place of one variable there are several variable are there. So single several variable we are considering in single any other variable. Suppose here is writing y minus x. Here is 1 plus 10x. Here should be 1 plus 10x. But not 10x. Here is 10y minus x. So y minus x considering equal to t. Then this function converted single variable t. Now next. Again problem solving on change of variable here. So here is dy dx. This is equal to in bracket 4x plus y plus 1 ka whole square. This equation 1. In place of x, here should be only single variable. Here is more than one variable. X and y is there. Addition or multiplication, addition or subtraction. So here is single variable there. So let 4x plus y plus 1 equal to t. This equation 2. And total this bracket considering equal to t. Now differentiating with respect to x on both sides. On both sides. So here 4 differential of x is 1 and plus dy dx and plus 0 equal to dt over dx. So now dy dx this is equal to dt over dx minus 4. dt over dx minus 4. So this is equation number 3. Now 2 and 3. From 2 and 3 putting in 1. So here dy dx means dt by dx and minus 4 equal to, here is t square. So now again dt over dx, this is equal to t square plus 4. Now this bracket plus 4. So this bracket dx cross multiplying this. So dt is equal to t square plus 4 and into dx. So apply variable separate. Apply VS method. VS method means here is t square plus 4. So variable separate dt upon 4 plus t square and equal to dx. Integrating on both sides. So now here 1 upon 2 tan inverse t upon 2 equal to x plus c. So this is answer. This is complete. Here c is the arbitrary constant. So this is complete solution of this question. 1 upon 2 tan inverse t upon 2 equal to x plus c. So this is the method of change of variable. Okay. Next. Method 3. Homogeneous differential equation. Homogeneous differential equation. First, we are discussing about the definition of homogeneous differential equation. What is homogeneous differential equation? So a differential equation of the form this. First of this is the form of homogeneous. Here is numerator. Numerator is other function. And in function is the two variables are there, x and y. But all variable have in each term same degree. In each term, all variables, sum of all variables have equal degree in numerator and denominator. Denominator is other variable phi x comma y. So in a differential equation, we see that in each term, the sum of degree of all variables are equal. Then that is known as a homogeneous differential equation. We are giving here some examples. Example 1, dy dx equal to 3xy plus y square. Dy dx, here dy dx equal to 3xy plus y square upon 3x square plus xy. We check this function. This function is homogeneous or not. In numerator, first term is x into y. X has 1 degree, y has 1 degree. Total degree is 2. And here second term is y square. So y square degree of y is 2. And denominator is x square, degree of x is 2. And second term is xy, this is into here. So here is 1 and 1 degree, total degree is 2. So each term of this function have 2 degree. So this is known as a homogeneous differential equation of second degree. Similarly, in example 2, x square and dy and plus y, x plus y square and dx is equal to 0. We multiply y here. Then we check every term, we check here. Here is x, power of x is 2. Here is y into x, here is 2y, and both have 1 degree. So total degree is 2. Here is y square. So degree of this function is 2. So each term has 2 degree function. So this is known as a homogeneous degree function. Homogeneous differential equation. Now procedure to solve the differential equation. What method, what procedure we apply in this differential equation, homogeneous differential equation? So the method solving given differential equation this. In this differential equation, we let y equal to bx. Here, putting, to solve this equation, putting y equal to bx or x equal to by, any one, or either this or this, and differentiating with respect to x. So here is dy dx is equal to b, v differentiation of x is 1 plus x differentiation of b dv over dx. Similarly, this function dx over dy, the differentiating with respect to y here, with respect to y, here with respect to x. So dx over dy equal to v into 1 plus y into dv over dx. Okay, so these value putting in equation 1. So b, then from equation 2 and 3 putting in 1, then we get here b plus x dv over dx, and x putting value up by bx. Okay, so x is cancel out. Here is functional total fb, b plus x dv over dx. Here we get only function of b here. X cancel out. So this equation, now RHS term same variable in numerator and denominator taking common, and after cancel out we get only function of t here, function of t in RHS. Okay, so now x dv over dx equal to fv. Here is t dot, here is b. fv minus 1, fv minus b, b is minus, so fv minus b this. So now equation 5 using method 1, variable separate, then this integrable this. Now here is dv upon x dv equal to fv minus v and into dx. So now variable separate this, dv upon fv minus v equal to 1 upon x and dx, integrating on both sides. This is variable separate, then we integrate this. Okay, so now this integration problem based on method 3, homogeneous differential equation. So I am solving this differential equation with the help of homogeneous differential equation. Question 1 is x square dy plus x plus y square and dx is equal to 0. This equation 1. Now here taking y equal to bx, put y is equal to bx here, differentiating with respect to x. So here dy dx, this is equal to b into 1 plus x dv over dx. This result, this equation, this result is 2 and this is 1 and this 3. From 2 and 3 putting in 1, we get. Then this result is, first of all I am writing this equation dy dx. This equation writing as dy dx is equal to dy upon dx is equal to minus yx plus y square upon x square. Putting this value, dy dx is this from 2 and 3. So here is b plus x dv over dx equal to minus y equal to bx into x plus y की जगह b square x square upon x square. X square is cancel out. So b plus x dv over dx equal to minus. Here x square is common. So here is b plus b square upon x square. X square cancel. So here is x dv over dx minus b square and minus b. So x dv over dx, this is equal to minus 2b minus b square. Now next this one, minus b square. So here x dv over dx minus b square, minus 2b. Here is minus 2b. So now this integration. Next, taking variables separate. Here. Separate. So here dv upon 2b plus b square equal to dx upon x and minus sign, integrating on both sides. So now how we can integrate this? So this result is dv upon b is common, 2 plus b and equal to minus log x plus log c. This integration of 1 upon x, integration log x and plus log c. We write here log c upon x. And in this side, We are breaking by partial fraction here. So 1 upon 2 plus b and 1 upon b. So 2 plus b minus b, minus sign. So 2, 1 upon 2 divide here. So I am writing this directly dv. So integration this 1 upon 2 and log b plus minus log 2 plus b and equal to log c upon x. C upon x. So this 2 multiply to here c square. Now log b upon 2 plus b and this equal to log c upon x ka whole square. Log is cancel. Final answer is b. Putting b equal to y is equal to bx, then b is equal to y upon x. Putting this value. So here answer is this one. Answer is putting y equal to b equal to y upon x log y upon x upon 2 plus y upon x and equal to log is cancel out log c upon x ka whole square. Log is cancel. So here x y upon x cancel y upon 2x plus y equal to c square upon x square. So this is answer. This is complete answer of this question. Next, so I am same solving this complete here. This equal to I am writing here 1 upon b is common. So here 2 plus b and dv. This equal to minus log x and plus log c. So now here integration 1 upon 2 plus b and minus 1 upon b. So this is by partial fraction using by partial fraction here. So 2 plus b minus b cancel 2. So here multiply by 1 upon 2 dv. This equal to here log c upon x. So 1 upon 2 this is log b and minus log 2 plus b and equal to log c upon x. So here this 1 upon 2. So 2 taking this side, this 2 log c upon x and here is log b upon 2 plus b. 2 plus b. So putting y equal to b equal to by x. Y equal to bx. So this implied that b is equal to y upon x. So this question is log y upon x upon 2 plus y upon x equal to this taking square log c upon x ka whole square. So log is cancel. So y upon 2x plus y equal to x is cancel. So this is c square upon x square. Final answer yx square upon 2x plus y equal to c square. This is complete solution. Okay, so this is the solution of this differential equation with the help of homogeneous method. Next, problem based on method 3. Method 3 homogeneous differential equation. This problem I am solving dy dx equal to y upon x plus x sin y upon x. So here is this term numerator and denominator yx. So this is variable separate. So now here putting y is equal to bx. Y is equal to bx. This is not here x. This x is not here. This is wrong. So y is equal to bx. This equation 1. So differentiating with respect to x on both sides. This equation 2. Y equal to bx. Differentiating with respect to x on both sides. Then we get dy dx. This is equal to v into 1 plus x dv over dx. This equation 3. From 2 and 3, putting in 1. So dy dx means b plus x dv over dx is equal to y equal to bx upon x and plus sine y in bx upon x. X is cancel out this x cancel out. Here b plus sine v. Here is b plus x dv over dx. So b is cancelled. Here x dv over dx and this is equal to sine v. Using variable separate method. Using method 1 variable separable here. So x dv is equal to sine v dx. So now here dv upon sine v equal to dx upon x. So this is cosec v dv equal to dx upon x. Integrating on both sides, cosec x का integration log 10x y2 log 10x y2 equal to log x plus c. So this log c. Integration cosec x dx equal to integration 1 upon x dx. So integration log 10x y2. This is the integration. Integration of cosec x dx equal to log 10x y2. This is the differentiation. Or log cosec x minus cot x. ये भी formula. Cosec x minus cot x. So this equal to log x plus log c. So this equal to log xc equal to log 10x y2. Log is cancelled. 10x by2 equal to xc. This is the solution of this question. Next question based on homogeneous differential equation, that this y square minus x square y square minus x square and dx plus x square dy equal to 0. The equation 1. Now putting y equal to bx. So y equal to bx, dy dx is equal to b into 1 plus x dv over dx. This equation 2, this equation 3, from 2 and 3 putting in 1. So here we get here, first of all I am writing this question dy upon dx. So dy upon dx is equal to here dy upon dx. So here x square, this minus x square dy upon dx. This goes to this side, dy upon any y square minus x square upon x square. So now this result is x square minus y square upon x square dy upon dx. So this equation is simplest equation in the form this 4. So this result putting in 4. So dy dx means b plus x dy over dx dv over dx. This is equal to x square minus y square means b square x square upon x square. X square is cancelled. So now here is y equal to bx. X is not. So this result is b plus x dv over dx equal to 1 minus b square. So b square taking this side, x dv over dx equal to 1 minus b square minus b. Now equation this is 5. Here using method 1 using. So now solving here बात में था x dv over dx, x dv over dx equal to 1 minus b square minus b. Okay. So now this bracket is 1, cross multiplying using method 1. So cross multiplying here. So this here is x dv, this is equal to 1 minus b square minus b and d dx. So here variables are not separate. Now we are making variables separate. So this goes to denominator dv upon 1 minus b square and minus b equal to here is dx upon x. Integrating on both sides and plus here log c. This is arbitrary constant. So log x plus log c. So here is log xc. And now in this side we are integrating the minus taking common dv upon b square plus b minus 1. So integrating, making perfect square. I am integrating with making perfect square. So now here minus common integrating dv upon here b square plus b and plus here adding 1 by 4 and minus 1 by 4 and minus 1 equal to log xc. Now this integrating dv upon here b plus 1 by 2 का whole square and minus 5 by 4 root 5 by 2 का whole square equal to log xc. Now this here dv upon root 5 by 2 का whole square minus b plus half का whole square and equal to log xc. So here we are using integration. This integration 1 upon a square minus x square dx. This integration we are using this integral here. Formula using formula this a square minus x square. So this integration 1 upon a plus x and a minus x. So now dx. This using here 1 upon a minus x, a plus x, a minus x upon a plus x. So here plus. So 1 upon 2a and dx. So this 1 upon 2a log a plus x and minus log a minus x and 1 upon 2a log a plus x upon a minus x. This formula is applied here. Then we get integral this. Then we get integral this like method 4 linear differential equation. Linear differential equation. That is dy dx plus py is equal to q, where p and q are functions of x. Functions of x. So now to solve one, let us consider a factor, a integrating factor if is equal to e की power integral p dx. This is 2. Now multiply by this factor to the differential equation. Differential equation 1. Then we get dy dx e की power integral p dx plus py e की power integral p dx equal to q e की power integral p dx. So now in LHS I am writing this function integrating y into differential of y into e की power integral p dx and equal to integrating q e की power integral p dx. So after integrating this differential, this cancel to this. Here is y e की power integral p dx and is equal to integral q e की power integral p dx and dx plus c, dx and plus c. So this is constant. So this is formula to solve the linear differential equation. And IF integrating factor is e की power integral p dx. We apply this formula to solve any differential equation. I have given here one example. Dy dx plus 1 upon x by equal to q x square. This is a differential equation. How we can solve? Now solving this differential equation. Now here comparing dy dx and plus py is equal to q. So now p equal to here 1 upon x comparing. After comparing p equal to 1 upon x and q equal to 1 upon x square. So IF is e की power integral p dx. This equal to e की power integral 1 upon x dx. This is e की power log x. So this is x only. IF is x. So multiply by this to each function. Now apply formula y into if equal to integration q into if and into dx plus c. This is formula. I have proved already. So y into if is x. Integration q into if is x. And q is 1 upon x square and dx plus c. 1x is cancelled. So integration of this by x is equal to this 1 upon integration 1 upon x dx plus c. So now yx is equal to log x plus c. So this is solution of linear differential equation. Now next question I am solving this. Dy dx is equal to plus dy dx plus here is log 1 upon here is sec square x and y is equal to here is 10x. Suppose this question. So comparing this dy dx and plus py is equal to q. Now p is sec square x and q is 10x. So now IF integrating factor e की power integral p dx and this e की power integral p dx p is sec square x and dx. So integration of this e to the power 10x and dx 10x. Here I am writing sec square x. This is z sec square x. The e की power 10x. This is the IF. Now formula using formula to solve the differential equation. Y into IF equal to integration q into IF whole dx plus c. This is basic formula to solve the linear differential equation. So here is y if e की power 10x equal to integration q is here sec square x into e की power 10x and dx plus c. So now integrating this y into e की power 10x equal to here considering 10x is t. Let 10x is t. Differential of sec square x dx is equal to dt. So this question convert in e की power t and dt plus c. Now y into e की power 10x equal to integration of e की power t is t and plus c. So y is equal to e की power 10x and equal to e की power 10x plus c. Dividing by 10x. So final answer is y is equal to y is equal to this 1 plus c upon e की power 10x. Now this equal to 1 plus c e की power minus 10x. So this is answer. This is the solve this differential equation. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.